we are with example 5. Dropping my paper here. Here we are with example 5, and we are asked to verify again. Remember what verify means. You have an equation this time. We got a left side and a right side, and the goal is to prove that these things are equal to each other. They're called identities because it's just a fact that the left side equals the right side. But you actually have to prove it. So what we're going to do is we usually have been like working with the left side. According to the book, you can work with either side. So what we're going to do is we're going to actually, you want to work with the more complicated side. It looks over here like the right side is the more complicated side. The left side is just secant y plus tangent y. The right side is a fraction, cosine y over 1 minus sine y. And this is going to give us an opportunity to use one of these thoughts here, which was, hey, look for opportunities to factor, add fractions, FOIL, conjugate, split a fraction, add a fraction, all those things. So let's look at trying to make that right side look like the left side. What I see on the right side, I say cosine y, and then the bottom I see a binomial, 1 minus sine y. 1 minus sine y. So what I want to do is I want to think, okay, maybe conjugate. When you see a binomial on bottom, it's not always the case that you need to use the conjugate, but you might pop it up in your head. Maybe the conjugate will help me. So what the conjugate is you take the conjugate of the denominator, 1 minus sine y, so the conjugate is 1 plus sine y. And you multiply the top and bottom by 1 plus sine y. All right, now you go, how's this going to help me out? Over on the top, I'm going to head and I'm going to distribute this. It'll make cosine y plus sine y cosine y. So I'm going to have cosine y from here and then plus sine y cosine y. It really doesn't matter how you write that other piece. You could say cosine y sine y or sine y cosine y. It doesn't matter. Then the bottom, remember, these are conjugates. 1 minus sine y and 1 plus sine y. When you FOIL two conjugates, when you're doing your FOIL, L, you can skip the O and the I. You can just do the F pieces, which 1 times 1 is 1, and do the L pieces, which negative sine y times positive sine y makes negative sine squared y. And then I'm just going to copy this side here, secant y plus tangent y. The reason why the conjugate helps a lot is because it creates something here like 1 minus sine squared y. Why is it good to create that? If you look on your identities, that very first one in the Pythagorean identities is the one that says sine squared, and I use x, sine squared x plus cosine squared x equals 1. Well, you can always manipulate this so it looks like 1 minus sine squared. So what I'm going to do is just minus the sine squared on each side. And then I would get cosine squared x equals 1 minus sine squared x. So using the important identity, sine squared x plus cosine squared x equals 1, you can move it around and rearrange it so that you can have a 1 minus sine squared equals a cosine squared. This gives me permission to take this denominator right here, which is 2 pieces, and turn it into 1 piece, which is just cosine squared x, which is what I'm going to do. I'm going to have cosine y plus sine y cosine y over now just cosine squared y, like that. And then here's going to be secant y plus tangent y, like that. Okay, now here's one thing I want to know is I'm working the right side, and I want to make the right side look like the left side. The left side is clearly 2 pieces, separated here with the plus sign. It's this secant y plus tangent y. Over here on the right side, I've got 1 fraction. That's not technically 2 pieces. But what I can do, if you ever have a fraction, and if you have 2 pieces on top, so if you have a fraction, you have 2 pieces on top, and you have 1 piece on bottom, you can split it so that you have this piece over cosine squared y plus this piece over cosine squared y. It would be like this. Say that you had like 5 plus 3 over 4. Okay, this is 8/4, but you can split it to where it says 5/4 plus 3/4. You can go this over 4 plus this over 4. And that's what we're going to do here. That's how you can take with the 1 piece and split it into 2. So to show that, I kind of do the opposite of when I combine. I go, hey, I'm going to make 2 separate pieces. I'm going to take one piece and turn it into 2. The first one is going to be cosine y over cosine squared y. And the second is going to be sine y cosine y over cosine squared y. Got it. Then I just rewrite the left side because I haven't done anything to it. There. All right, now looking at this, cosine y over cosine squared y. Remember, cosine squared y is really just cosine cosine. So this cosine on top will cross off one of the cosines that are being squared here. The way I would usually draw it is I'd cross this out and go, hey, this one cosine is going to just basically make that cosine not squared. If you're not sure about that, let me just explain. Like if you have this x over x squared, this 1x would cross this down to just becoming like 1 over x. So x squared over, or x over x squared would end up just being 1 over x. Likewise, if you had, say that you had like up top, say you had like x squared over x, this 1x would cross this down to not be squared, and you would end up with just x. So this ends up being, that'll just end up being 1 over cosine. Same thing over here. This cosine right here will take off one of those cosines. Remember, that's cosine cosine. So this cosine here will knock off one of those cosines. So I can do this. Again, one thing that I really want to point out, notice there is no plus sign between that sine and that cosine. If there was, you wouldn't be able to do this. If you had sine x plus cosine x over cosine x, you couldn't cross those out. And you sure as heck you couldn't cross those out either. So that plus sign makes life a lot more miserable. Be thankful when you don't have them. This piece had them, so I couldn't just use that cosine and that cosine to do some crossing out. But when I split it, there was no plus sign in here or in here. Gives you that ability. So then, with that crossing out, I've got secant y tangent y equals, this is 1 over cosine y plus sine y over cosine y. And I'm pretty much, you could hopefully see where this is going. I can turn this piece, using my identities, 1 over cosine y is going to turn into secant y, right here. Sine over cosine is going to turn into tangent y. And then I'm going to pretty much be done. So this is secant y plus tangent y equals secant y, that turned into secant y, plus tangent y, that turned into tangent y. Now, that's pretty much it. I do want to point out one thing, just to be clear. When I said we have this, so you had cosine, so we had cosine y over cosine squared y. And I went through and said this, we'll just cross that out. Remember that cosine squared is really cosine cosine. And then you're allowed to cross out like this. So that's how it leaves you with just 1 over cosine y, like that. All right, and that's it for example number 5.